Hello everyone, my name is Deniz ÖZTÜRK. I am second year student at Bilkent University at Computer Science Department. This is my Physics 101 project video. The aim of the experiment is observing the conservation of energy, which is a fundamental law of physics that tells us in isolated systems the total energy must be conserved. Let's start with my equipments. There is a cube with written the sine value of my inclined table's angle. There is a ruler with 30 centimeter. Of course, an ear table with its puck and its own chronometers, which is adjusted to 50 milliseconds between dots. This is my system at all. Also, I use a balance which shows me the weight of the puck. As you can see, the puck is 430 grams. At the very beginning, I throw the puck from the lowest point of the inclined table to the highest point. Then, to prevent confusions, I stop the machine at the highest point and take another point with the same height to not affect my calculations, because if the puck follows the same path, the dots may cause confusions to understand which is the ascending path and which is the descending path. After I choose that point which will not manipulate my calculations, I put the paper on the air table again and lead it to make a free fall. After performing the experiment, I calculated the displacement of the puck while it was on the ascending path, which is the same as the descending path. I calculated displacement as 41 centimeters. Moreover, I calculated the number of dots to calculate the total time passed, which is 0.75 seconds. I used the equation that displacement equals initial velocity multiplied by time plus 1 over 2 system's acceleration times time squared. I assumed the gravitational acceleration is 9.8 meters per second squared. Since every variable is known, it was trivial to calculate the initial velocity, which is 1.145 meters per second. Then with these values, I figured the initial potential energy and kinetic energy, from which I calculate the initial mechanical energy. Then for other 6 points, I calculated potential energy by the formula m times g times h. For calculating the height, I used the formula displacement times sine theta. Furthermore, to calculate the kinetic energy, I use the formula 1 over 2 mv squared, for which I calculate the velocity by the formula velocity equals initial velocity plus acceleration times time passed. Then by these values, I fill the table 1 and the graphics as shown. The results of the experiment are almost same as the theoretical expectations. However, there are some little errors which may be caused by the air friction or minimal friction by air table, or by human being. What I mean is maybe I apply an undesired force when I leave the puck to freefall. In my experiment, the error percentage was 1.9517. In my project, I reference to University Physics book volume 1 to use the formulas and assume the gravitational acceleration.